Okay, so we're starting where we left off. This is chapter 7. So we were talking about arrays the other day. And so hopefully we have an idea of what a one-dimensional array is, because a lot of times we will also have two-dimensional arrays. So we have to think about it kind of like a table this time. So instead of just having rows or having a column, so if you were thinking about a one-dimensional array, you would think about one student in particular and all of their grades for all of their tests, all of their assignments and everything. That would be a one-dimensional array. But if I wanted to have all of the students in the class and I wanted to have all of their grades for all of their assignments and their tests, that would be a two-dimensional array. So if you think about it, whenever I put my grades, a lot of times we use something called a spreadsheet to do that. And so I would put like the students' names on the one side and then the assignments and the tests at the top, and then I would have all of their scores, right? And so I could follow through the student lined up with the assignment and figure out what their grades are for that. And that's how it looks in Canvas, when we have a grade book. So think of it like a table where you have rows, which would be usually the student's name, and then you would have the columns, which would be the assignments or the tests that you're doing, okay? So when we're doing a two-dimensional array, we have something like that. We are gonna have rows and columns, because again, we're thinking like a table, so think like, okay, rows could be like the names and columns could be like the assignments for the scores. We have to say how many rows and how many columns. You don't have to have the same number of rows as columns, of course, because if you think about it, how many students do we have and how many tests, they don't have to be equal, right? And then when we're doing it, when we have the square brackets that says that it's an array, we're going to put two sets of those. The first one's going to be the row and the second one's going to be the column. Okay, everybody with me so far? And so just like before we had a size declarator, you put a size declarator on here that says that, okay, we're going to have 4 rows and 3 columns, and you can put the numbers in there, or you can put a variable that represents the numbers. It's easier if you put a variable that represents, because then you can easily modify that. You can see where that's at. And if you use that throughout your program, you can use the variables instead of the numbers. And if you happen to change that, it's more flexible to change it in that one place as opposed to throughout your program wherever you have it. So try to keep that in mind. So here we can see visually what that looks like. I know the only thing strange about this is probably that we start at 0. That's the thing we have to get used to. So just like in a one-dimensional array, we start our array at 0, our index location or our subscript. We also start counting our two-dimensional arrays at 0. So if you're thinking like rows and columns, you could think, okay, I do have 4. No, that's weird. Okay, so I have the opposite, right? I have 3 rows and 4 columns. Okay, sorry about that. Sometimes I need to change these slides. So when you're looking, I have 4 columns and 3 rows, okay? And I know that it only goes 0 to 2, and that's because, again, you start at 0. So if you go 0, 1, 2, that actually is 3. And if you go 0, 1, 2, 3, that actually is 4 columns. Okay, so when you're talking about like the first score in the table, you would actually go row first, which would be 0, and then column, which would be 0. So 0, 0 is the first score. So if you wanted to pull that score from that table, you would say scores and you would put the square brackets like that, 0, 0, just like that, and it would pull the score. If you want to put something into it, you would use that representation just like that. So here you can see, I am not sure. I really need to fix this slide. I'm sorry. This should just be scores. I don't know. I mean, I'm going to stay. Oh, we do have exams. I'm sorry. I thought we were doing scores. Maybe another side. So exams. 2 and 2. Remember that we're starting with 0. So we go row 2, column 2. It would be this one here. We're putting a score into. We're putting 86 in there. So go row, then column. And just remember to start counting at 0, which is very unusual. Everybody okay with that? Okay. So if you can see this, this is an example of how to work with it. It gets a little more complicated. We could use a basic for loop to work through an array, but if we have a two-dimensional array, we have to have a nested loop. We have to have a loop inside. So one is going to handle the rows and the other one's going to handle the columns. And so it becomes a little tricky, but if you think about it, it's not too bad, hopefully. So in this program, we have 3 divisions. So we have a variable here for divisions, and we have 4 quarters. Okay, so we have a 3 by 4. So we're going to have 3 rows and 4 columns. Okay, and then here, when we're doing it, if you look, you have a for loop on the outside and you have one in the inner. The outer one handles the divisions and the inner one handles the quarters. Okay, so what we're going to do is what happens is you always start at 0 because your array index starts at 0. So you're going to start your for loops at 0. And the outer one's going to handle the division. Okay, so it's going to be on division 0. And then what's going to happen is it's going to go into the inner one and it's going to go to quarter 0. Okay, it's going to handle quarter 0. And so it's asking you to enter sales for the division 0, quarter 0. Now, because people don't want to see it called division 0, quarter 0, we actually display it as 1 just because it looks more normal than saying division 0, quarter 0. We say division 1, quarter 1. So we just add that 1 on there just for display purposes. But they're going to enter the data, but it's actually going into 0, 0. Okay. Then what's going to happen is it's going to go back and go to the next quarter, but it's not going to the next division yet. So we're still on division 0. Then we were on quarter 0. Now we're going to quarter 1. Okay. Then you're going to enter the sales for that. So it would be row 0, column 1. Okay. You would enter the sales. Then it would go row 0, column 2, row 0, column 3. When it gets to 4, 4 is the number of quarters that we have, so it wouldn't be less than and it would stop. So it would go 0, 1, 2, 3, and then stop. Okay, so we are going to handle all the quarters for the division before we move to the next division. And so when you get the inner for loop, you have to get through the inner for loop before you can go back and increment the outer for loop. So it happens to get through all of the quarters, and then it comes back. This just prints a blank line, so it looks nice. I'll show you in the output. Then it comes back and moves to the next division. So if we were on division 0, now we're on division 1, right? Then we get back in the inner loop for the quarter, we're on quarter 0. So division 1, quarter 0, right? Then we add the sales for that. Then we're on division 1, quarter 1. Then we're on division 1, quarter 2. Then we're on division 1, quarter 3. And then we stop, right? And when we stop that inner loop, we go back and go to the next one of the division, and we're on division 2. Okay? So then we're division 2, quarter 0. Division 2, quarter 1. Division 2, quarter 2. Division 2, quarter 3. We stop. When we reach all of the quarters, we stop, and we're done. Okay. So when we reach all the quarters, we go back and we do the division. And when the division, reaches the end, when we have 3 of them, and we go through all 3, we stop, and we're done with it. Okay. So what I want you to try to remember is when you have an inner for loop. I know we talked about inner for loops before, but they're a little challenging. So we have to know how they work. Think about, we have to finish that before we get out of it. And then once we get out of it, we go back and we increment the outer one. And then we start all over again because we get stuck in the inner one again. We have to get through the inner one. So think about it as like, we're finishing, like if I were having a table again of students and their scores, I would want to go through the row for the student and go through all the columns for all the scores for the student. Then I go to the next student and I enter all the grades. Okay, you could flip it and go the other way, but it's going to do all of the columns for that particular row. Okay, and then this one, once we have this is the same thing. And the reason for this one, except the body of the for loop is different. This one was getting the data in. This one is just adding to the total. So you can figure out what the total is. So every time it gets in a new quarter, it adds that to the total. So it goes through with the first division, the first quarter, and it adds that. And it moves to the next quarter, and it adds that. Next one, next one, next one. And then it goes to the next division, and the quarter, and the quarter, and the quarter, and then the next division, and the quarter. And is everybody with me? Okay. So it's going to add to the total. And then when it gets outside of that, this is outside the loop, it's going to print everything. So if we take a look at the output, it looks like this. Because this data being entered is our first set of loops, the nested loops. And so remember that we are actually on division 0, but we're displaying it as division 1 because it would look weird if we displayed it as division 0. Okay. So we're actually on division 0, quarter 0. Okay. But we display it as a 1. And then it moves to the next quarter, the next quarter, the next quarter. But we stay on the same division because remember, division is actually our row and the quarter is actually the column. And we're finishing the columns in the inner loop before we go back and we increment the row. And then once we increment the row, that would be the next division, which again, this is really division 1 here, but we display it as 2 to make it look nice. We finish this division with the inner loop of all the quarters, entering the data, and then we move to the next division. And then we enter all the quarters. Everybody see that? And then once we get done with that, the next loop handles the total. So the next loop with the inner loop handles the total. And then once we're done with that loop, it displays the grand total of that. Are you okay with that? Okay. And it might take some time looking at that and kind of, reasoning through that. So make sure if it's tricky, that we're working through that to try to figure that out. Okay, sometimes instead of going, each index and putting the values in, we might want to set up the initialization list just like we did with a one-dimensional array. So with a two-dimensional array, if you want to initialize it with values, you actually put the inner set of curly braces with each of the values separated with a comma, and then these outer set of curly braces around the whole thing. And so when you're finished with a row, you put a comma. So you could tell like, this is row 0, this is column 0, column 1, and then this is row 1, column 0, column 1. Okay. It's kind of nice if you set it up like this instead of putting it all in one line, because now you can see that it looks like a table like this. You can see that this is a row and this is a row, and then these are the two columns. But you could, in your code, you could just move this up to be on the same line, but then it's a little harder to read that way. So some people will set it up so it actually looks like the table in their initialization list. So you can see how this setup kind of looks like this, and it helps you kind of identify the rows and the columns a little easier than putting this up on the same line. But it's fine to put it up on the same line if you can visualize it. That makes sense to everybody? Okay with that? Okay. So again, think of this as your row. This is row 0, row 1. This is column 0, column 1. Ready with me? Okay, and we're going to practice with this a bit to make sure everybody's okay with it, but I just want to make sure everybody gets the concept of it. And if you don't initialize something, if you have a size declarator there that says that you have so many rows and columns, then it automatically initializes to 0 or null. But if you leave the size declarator off, then it won't know, and so it will only do what you have in your initialization list. Okay. Now, when you're doing it as an argument for a function, you have to, just like before, when you're doing the prototype, you have to put that it's an array. But the thing is, you have to put how many columns you have, the size of the columns, and then you have to put the size of the rows over here. So you did put the size of the rows over there before, but the size of the columns goes in the second square bracket. So it's a little different if you have a two-dimensional array. And then, of course, the header kind of looks the same, except you have a name here. Okay, a name for the array and a name for the size for the rows. And then how you would use it is you would put the name of the array and then the size. Okay, so we have an example that's going to put, it's called show array. It's just going to display the values. So here we have an outer loop and an inner loop, because if you're working with a two-dimensional array, you have to have an outer and an inner loop. So this one's going to handle the rows and this one's going to handle the columns. What happens is, again, you want to start at 0, and then you're going to go less than the number of rows. Rows is the size here, and then columns is the size here. So when you display it, if you use the X, which is the outer one, that would handle the rows, and the Y is the inner one, would handle the columns. Okay, as it's moving, because remember it starts at 0 and it goes through. So remember it would do the column 0 first, and then it would do all of the rows for that column, or I mean the row first, and then all of the columns for that row. And then it would do the next row and all of the columns for that row, and the next one and all of the columns. And then once it finishes the rows, then it's done. Okay, so that would print for us. Okay, and then again, you don't have to display it like this, but a lot of people will, because you can see a bit more. Like this is a row, and these are the columns. If you do it like that, this could all be one line of code if you wanted. So we have 2 different tables. So this table has these values and this table has these values. And so when you call the show array and you pass in the arrays, it's going to just print the values back out for you. I think I have it on the next slide. Maybe not. It's just going to print those values. So if you want to try that one, you can copy that code and try it. And we'll do some practice programs so you can actually see it and running and play around with that. All right, so this one has 5 by 5. So you can see that you have 1, 2, 3, 4, 5 rows and 1, 2, 3, 4, 5 columns. And this always confuses people. The size declarator is actually how many you're going to have. But the index locations is where you start at 0. So that's when you do like the one last. But when you're talking about the size, that's actually how many you have. Okay, when you do your regular counting. Okay. So here, if you wanted to sum everything in that two-dimensional array, if you wanted to sum all of these, you would do an outer and an inner loop, start the outer at 0. And then once you have this down, you can actually just keep using these for loops for whatever you need. Like if you have a two-dimensional array, just use the for loop example because it's already set up for you. Like this one's going to go less than the number of rows you have, and this one's less than the number of columns, right? And normally we do row first, then column, but you can switch it. And so inside here, we're going to put whatever the name of the array is. So the name of the array was called numbers. And then whatever row we're on, that would be this number that's moving through. That would be our index that's moving. So it goes 0, 1, 2, 3, right? And then the columns would be the inner loop, which goes 0, 1, 2, 3. So the first time through would be 0, 0, which is the first value. It would get added to the total. And then the next time through, we would actually still be in this inner loop. We would be at row 0, column 1, and we would add it. And then row 0, column 2, we would add it. Okay. So we would actually, when we're doing it, we would go through and we would take this number and add it to the total. Then we would still be on the same row. We would move to this column and the inner loop and add this number. And then this column and add this number, this column and add this number, this column and add this number. Then this is where the outer loop flips to the next row. And then we do column, 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 column in the inner loop. And then we flip to the next row, which is the outer. Then add this one, this one, this one, this one, this one. Then flip to the next row. Does everybody see that? So the columns are the inner and the row is the outer that flips it. Okay. And so at the very end, after you're out of the loop, make sure you're out of the loop. Otherwise, it'll display it every time you display the total. You do have to make sure that the total variable is declared before your for loops, because if you declare it inside your for loops, then it won't know what it is when you come out of it. So make sure that that for loop or that total variable is declared before. Okay. I don't know if I have it here. Here it is here. So don't do it inside your loop. Okay, if you just want to sum the rows, it looks a little different. So that one summed everything, the rows and the columns. But if you just wanted to sum the rows, let's say you're talking about like the students and their scores. If you just wanted the students' scores, for example, like one student's scores, to know what the total was, or we're going to talk about in a second, what if you wanted to know what the average was for a particular test? You could do it that way too. So if you want to know what the average is for a particular student, or you want to know what the average is for a particular test, you can just sum that instead of summing all of them, okay, and figuring out the average. So here we have a list of student scores, okay. So it looks like this. This part, again, is the same. And then, so this is the number of students and this is the number of scores, except the difference is you'll notice that there's a total equals 0 here. That's because we have to reset it. So what happens is when we are on a particular student, and we come in here and we're doing their scores. So we're doing their first score. We're adding it to the total. We're doing the next score. We're doing all of their scores, right? In this inner loop. I notice there's no curly braces, so it only does this one line in the inner loop. Okay. So once it does all of the scores for that student, it's going to pop out. And the next thing it's going to do, because it didn't reach a curly brace for the for loop up above, is it's going to do the average. So it's going to take the total for that student and get the average. Okay. And then it's going to display the average for that student, okay? And we're not doing this outside the for loop because we're going to then move to the next student. So we are doing this inner loop for all the scores for that student. So going through the whole columns for that student, every score. Then once we finish that, we are showing the average here. And then we're going back to increment to the next row, which is the next student. And we're resetting the total. Why do we reset the total? Because we're on the next student now. Okay, so we want to throw that out and go to the next student. We'll reset the total. We go in the inner loop. We do all the scores for that student. Display the average, then go to the next student. Reset the total. Is everybody with me? If that makes sense, we flip it for the next example. Okay. So here, this is going to do the scores and the students. So we flipped it. So here you can see we're doing the columns and the scores, and then this one does the students. So it's just flipped, but it's the same thing. The totals is 0, the average, and it's just the loops are flipped. You can go the other way. Okay. Does everybody have this? Does this make sense? You may want to actually paste this into online DB and try it and see if it works. So you have those examples to work from. And that's completely fine. Anything that's in the PowerPoint slides that you want to have as examples, that way you can use them for your assignments or your checkpoints, that would be fine. So you have it. So you know how to do an average of, two-dimensional arrays different ways. We are not going to work with three-dimensional arrays in this class or four-dimensional arrays, but it is possible. So when you're thinking about it, you're thinking about like all of the students in this class with scores, but if you start thinking about multiple classes, then you start thinking about cubes. So like if you think about in spreadsheets, I have a spreadsheet with a grade book for this class, but then I have multiple sheets. Okay, so that would be 3 dimensions. But we're not doing that. Okay. Okay. So one bad thing about arrays is that they are not flexible. Okay, so what I mean by that is when you create an array and you establish a size, once it creates the array, you can't change the size of it. So you can always err on the side of caution and go with a larger size than you think you need. And then that way you have extra spots. Now, in C++, if you go further than what the array size is, it will not throw an error. It will let you do that, but it won't work the way you want it to, because if you don't have the memory set up for that, then it's just throwing it out there wherever. And then you won't be able to pull those values, but you won't get an error. So that's good, I guess, but you won't have it work the way you want it to either. So we usually just go with, okay, if I think I might have 10 scores, but maybe I'll just go with 15 just in case, right? But then that's extra wasted space, right, that we have. So something to think about. Now, you can always, when I say you can't change the size, once you create it, you can't change the size. So you can always go back and like put in your size declarator a different size if you know you want to change it, right? But you can't have a size and then like I say I want 10 values for this array and then later go try to add an extra one on because it doesn't have room for that. So that's what you can't do. But with a vector, you can. So you can create a size for it and then you can add more later. You can remove them so it can shrink size, so it can change size. So that's one cool thing. But the only bad thing about it is all programming languages and scripting languages have an array, but they all don't have vectors. And so like in Java, Java doesn't have vectors, it has an array list. And so it's a little different for every programming languages how a vector or a list works, but in an array pretty much works the same in all languages. So it's universal, I guess, to all the languages. And so that's why we spend a little more time on arrays, because vectors are a C++ thing. And then once you switch languages, you won't have that ability to do that. But if you go with Python or Java, they all have arrays. Okay, so you're going to include this at the top with your preprocessors. And then you can say here, instead of the square brackets, you put little carets. I think they're called carets. I forget the plus than greater than signs. You can say what the size is. You can initialize them to something by putting a comma and putting what you want to initialize them. You can do an initialization list just like you can do with an array. It's just the syntax looks a little different, but you still have, those are curly braces. I know sometimes it's hard to see in the projector, but if you put parentheses, that won't work. But you separate all your values with a comma. If you do push back, then you can add elements to the end of it. You can ask the size of it, which is pretty cool. You can remove elements from it with a pop back. You can clear the whole thing. You can ask if it's empty, which is a cool thing to do. And so this is just a simple program that has like a simple array that's been initialized here with the values 10, 20, 30, 40, and 50. And so it has this vector and it's going to go through and print all the values in there. So it uses one of those basic for each loops. And so you put the name of your vector. What do you want to give it here? This could be any name you want. And then it's just going to print each one. Okay. These are some more that you may or may not use. Again, we're not going to spend a whole lot of time with vectors in this class because this is C++ specific thing. But I think they are pretty useful, and it's useful to know that they can change size where you are actually limited with an array. And so that's pretty cool to do because most languages actually do have some other form of doing a list that actually is more flexible than an array. Okay, so, all right. Any questions? I'm super excited to get started working with arrays. It's the last major concept that we have. And then pointers is going to help us understand arrays a little bit more because arrays are using pointers. So then we can walk through an array with pointers and kind of take a look at how that works. And so it's kind of nice to understand the memory allocation of arrays and how it works. And so I do like that. What I want you to try to do, we'll just take a few minutes to try to do it. I want you to try now, if you open up online GDB, we'll see how hard this is for everybody because we're trying to take small steps here. I want you to create an array with 10 integer values. Okay, do an array, not a vector, because I want to practice arrays. And then I want you to ask the user for 10 values and put these values into the array that you created. Okay, so create an array with 10 integer values, then ask the user for 10 values and put these into that array. Okay, so hopefully pretty easy. If you get that done, and that was pretty easy, this isn't a challenge. See if you can print those 10 values from the array. Only if you get that done. Print the 10 values from the array. Okay. Only if you finish the previous one. So see if you can do that. We'll just take a few minutes here, 5 minutes, see what you come up with. See if we understand step one. Okay. Okay, let me show you what I have, and then you can compare it to what you have, just because I want you to have time to do the checkpoint. So you can, hopefully you got at least this part. And so you don't have to put the variable in there for the size of 10. You could just put a 10 in there, but it is a little, usually consider a little better to do that just because you might use that in other places, like for this for loop. So for the for loop, you're always going to start at 0. I don't have to use the variable count. I could use I or any other variable name I thought was good. You're going to go less than the size. This is where it's useful. If you create a variable, it's useful to put a size here instead of putting 10 all the time. Because if you decide you want to do 5, then you have to remember to go change all those and do count plus plus. Now, because I'm entering 10 values into the array, instead of putting, each one into the array one by one, because if you were doing that for 100, that would be, very inefficient to do one by one, use a loop to do it. It'll start at 0. It'll ask you to enter an integer value. It'll put that one into count of the array, which is going to be 0, then 1, then 2, then 3, all the way to 10. That way, if I wanted to do 100, all I have to do is change this number here to 100, and now I have 100. I want to do 50, I change out one number there, and I have 50. And so that's what's nice about that variable. That variable changes, then I have everything else changed accordingly. Then I told you didn't have to get this far, but if you already had this loop, you could just copy it. And all you do is just change the C out to print the values. You can reuse the names that you had here because it's a separate loop, so it doesn't matter. You can use the same thing. So once you have the for loop established, you can just keep using that for everything you want to do. If you want to do totals, you want to do printouts, you're doing input, it's the same loop over and over again. If it's the one-dimensional array, and then once you have a two-dimensional array, same thing over and over again as well, most likely. So if I run it, it's going to ask me for values. Put some values in there. I just did 1 through 10, and then it just prints. Now, I didn't print them with spaces or anything. I probably should. I just printed them here. I can add like a space here or something to make it look nicer, or enters. I can do like an end line on each one, so it does it on a separate line, but I just put them here like this just to show you. So basic printout. Does everybody understand that code? Okay, so if that was hard for you, maybe, after you get your Rebel activities done and you get your exercise done, maybe try to do it again, but try it with 5 values and see, if you can do that, if you can reason through that and do that kind of thing. Okay. All right.